For decades, enterprise IT was defined by hardware. Companies bought servers, bolted them into racks, and hardwired their network. Operational capacity was strictly limited by the volume of physical metal on the floor. That rigid infrastructure shattered when the demand for data-heavy AI training coincided with a global shift to remote work. Traditional localized systems were not built to scale for billions of data points flowing through 1,000 different home networks. Buying more centralized servers does not solve a decentralized problem. Managing millions of home routers and unmanaged devices through manual labor is a logistical impossibility. The old model of hands-on maintenance reached its limit. Surviving this volume requires abstraction, a process in computer science that removes physical or spatial details to focus entirely on function. It separates the capability of the computer from the machine itself. For an enterprise to remain operational, the physical metaphor of the office server must end. To scale with modern data, IT systems must transform into a completely abstracted, fluid entity. Raw processing power was the first to dissolve. High-performance computing, or HPC, has shifted away from on-premise supercomputers toward cloud-based pay-as-you-go services. This allows organizations to rent thousands of servers for a specific workload and release them the moment the task is complete. Even standard cloud resources are moving toward deeper abstraction. While early cloud services relied on virtual machines that mimicked physical servers, those machines still consumed resources while sitting idle. Serverless computing architecture changes this by executing a specific function only when an event trigger calls for it. Because there is no always-on server, organizations only pay for the precise milliseconds of computation used. This creates a storage challenge. Modern software runs in temporary containers that spin up and die in seconds. If the computing environment is destroyed after the task, the data it produced must have a way to survive independently. Container-native storage solves this by virtualizing the physical storage across a cluster into a single software-defined pool. This ensures that application data persists, even as individual containers are created and deleted elsewhere on the network. Hardware has become an elastic utility. Software instructions now summon and dismiss processing power and storage capacity in real time, removing the need for upfront capital investment in machines. As the hardware layer disappears, the role of the administrator changes. Manually provisioning physical servers or patching software by hand is simply too slow to keep up with thousands of virtualized assets. Everything as code, or EAC, abstracts the management process by turning infrastructure setup into repeatable policy files. When all workflows are defined as code, systems can be audited, scaled, and secured automatically with a minimum of manual effort. A centralized control plane manages resources regardless of their physical location. Microsoft Azure Arc bridges on-premises servers, edge devices, and competing public clouds. From a single interface, users can provision legacy data center servers or audit databases on a competitor's cloud using native Azure tooling. Since the network now spans from employee homes to multiple clouds, security has moved away from the idea of a physical perimeter. Threat monitoring is now abstracted into managed detection and response, a service where AI-assisted experts hunt for anomalies across the entire global infrastructure. Administrators now manage these environments by orchestrating automated policies from a single point of logic, centralizing control over thousands of remote assets. This abstraction reaches the daily experience of the worker. The traditional desktop file, a fixed unit requiring manual saves and email attachments, has been replaced by cloud-native architecture. Collaborative file sharing shatters the idea of the static document. Instead, files exist as data blobs in a cloud database, allowing dozens of people to view and modify a shared dataset simultaneously in a real-time communal environment. The disappearance of the physical office led to the rise of workplace analytics. These tools use telemetry from collaborative apps to map productivity patterns and remote workflows, providing a view of team engagement without requiring face-to-face interaction. As the workers' patterns become data, the work itself is also being abstracted. Formative AI uses these data reams to generate high-fidelity synthetic information and adapt designs dynamically, solving complex problems and filling data gaps without human input. The workplace is now entirely unmoored from physical location. It has become an abstract, real-time flow of collaborative data and AI-generated outputs. The modern digital enterprise is an ecosystem that rapidly adjusts its resources to meet fluctuating demand. It is decentralized, driven by code, and largely invisible. This shift redefines the IT professional. The role has moved away from physical hardware maintenance and toward the high-level orchestration of logic and automated systems. With manual tasks handled by everything as code, serverless compute, and formative AI, human capital can focus on strategic problem-solving. Engineers design the logic of the system rather than managing the machines that run it. The organizations that will lead the next decade are the ones that move past the limitations of physical infrastructure and fully embrace the flexibility of the Great Abstraction.